Dear students, now our next topic of the chapter number 12 is use of the exponent. Use of the exponent to express a small number into a standard form. So, in this topic, we have to learn the placing a decimal point. If the number is given and we have to question that the placing a decimal point, that means the placing a decimal point also is used this activity for the converting the number into the standard form, that is the exponent form expressed into a small numbers into a standard form. This placing a decimal point means shifting a decimal point. So shifting a decimal point, that is there are the two variations. Once right to left means right to left, and another one is a left to right. So in this placing a decimal point, this concept consists of a left to right. If we consider, for example, if we consider the number 100, so in this number there is a no decimal point, but if we consider, so after 100 this is a decimal point, and we can also write down the any times of 0. Okay, so this is the number, now we just simply understand this 100 into 1. So our answer does not change. So 100 into 1 always equals to 100. There is a no change. But this one can also be written in the form of this is 100 into 10 raised to the power 0. 10 raised to the power 0. There is a no change. Because why? Any number whose power term is 0 always equals to 1. And 100 into 1 is equals to 100. There is a no change. But if we place this decimal point, means if we write down 10 into 10, that means what happened? When this decimal point transferred to the one digit here, after one digit, so this is a 10 number and into 10, and here order of the 10, power of the 10 is 1. So 10 into 10, 100. If we write down this 1 into 10 raised to the power 2, that means in 10 this is the decimal point, so 1 into 10 square is equals to 100. So 100 into 1 also 100. So in this step, the first, this is the number 100, this is the decimal point. After that we just place the one digit decimal point, and here just write down 10, here 10 raised to the power 0, here 10 raised to the power 1, and after that this is the 1, 2, 3, 4. There is a not requirement compulsory 4 times of 0. You can take the any times of 0 into 10 raised to the power 2. Means when if we consider the number 100 into 10 raised to the power 0, then this decimal point is transferred to the one digit from right to left. So this is the direction right to, and this is the left. So how many digits, how many places? 1. So therefore 10 raised to the power 1. If we transfer this decimal point up to the two places, 1, 2, that means 1.0, then 10 raised to the power 2. Therefore when decimal point shift right to left, then 10 raised to power increase or adding, that is positive. So this is the first part. Means when the decimal point is shifted from right to left, that time 10 raised to the power is increased. If we consider the number, simple number 100, so 100 into 10 raised to the power 0, it is possible because 10 raised to the power 0 always equals to 1. 1 into 100 is equals to 100. Then we just shifting the decimal point after one digit from right to left, so 10.000. Now so 10 point, then how many places decimal point is shifted? One place, so therefore 10 raised to the power 1. Next 1 point, So 0 0 0, that means the decimal point 1 point into, then the 10 raised to the power is increased, that is the 10 raised to the power 2. So 1 and 2 decimal point is shifted. So when the decimal point shift right to left, from right to left, then 10 raised to the power increase, 10 raised to the power increase. One more example is there. One example is there. So this example is, one more example is there. If you consider, forget it. If you consider the number, that means if you consider the number 10,000 or 1 lakh. So this is the number 1 lakh. Okay. Oh, so it's a 10 lakh. It's a 10 lakh. So here 0 0. If you consider this is a decimal point. Decimal. So this is the number. Now simply write down. We just write down 10 into, sorry, 1 into. That means decimal point is shifted from right to left. Right to left. That is this position. How many places? 1, 2, 3, 4, 5 and 6. So therefore we write down 1 into 10 raised to the power 6. 1 into 10 raised to the power 6. Understand? This is the first example. If we consider the second one example is, if we write down 15,432 into 0, decimal point 0. If we write down the 15.432 into 10 raised to the power, how many places? 1, 2, 3. So simply 10 raised to the power 3. Understand? So when we just transfer, shifting the decimal point from right to left, that time 10 raised to the power is increased. 10 raised to the power is increased. Now our next topic is left to right. If the decimal point is shifting from left to right, now left to right decimal point is shifting. If we consider one of the number is 1 0 0 0 0. So this is the number 10,000. And if we consider this is the decimal point, this is the decimal point. So here if 0.10000, and if we write this number is as 1 point, so here 10 raised to the power, how many digits? How many digits? So here simply write down 10 raised to the power minus 1. Minus 1. Because this decimal point is shifted from left to right. How many places? 1 place. So therefore place is decreased by 1. So therefore 1 into 10 raised to the power minus 1. It can also be written as 1 upon 10. It can also be written as 1 upon 10. Understand? That means when we shifted the shifted the decimal point from left to right, then the 10 raised to the power is decreased. So here the decimal point only shifting from one place. So therefore 10 raised to the power minus 1. Understand? So this is the first example. If you consider the second one example is 0.12345 and this is the 7. Now here decimal point, this is a very small number. If we transfer the origin as means 0.12345, 1 2 3 4 5 6 7, 1 2 3 4 5 and this is the 7, means only we transfer the decimal point from one digit. So decimal point place is that. So here, and if we write down, if we place the decimal point after the 7, so 1 2 3 4 5 6 and 7. So this is the number 7 into 10 raised to the power minus 6. 10 raised to the power minus 6. How many digits? 7 digits. 1 2 3 4 5 6 7. So therefore minus 7. How many places? Therefore minus 7. So when decimal point, when the decimal point shift left to right, right, left to right, then 10 raised to the power 10 raised to the power decrease, that is the negative, or it is also subtract, so this is the basic transformation. Okay, dear students, now our exercise is 12.2 and question number 1 is given. Express the following numbers in standard form. Some numbers are given in usual form. All these numbers are given in usual form. So our question is that write down is usual form into the standard form. Just standard form means write in the number in the short form. Some numbers are very large and some numbers are very small. So we have to question is that standard form, that is mean the short form. So here the first number is 0.000000000085. So it is a very small number. Then our question is that write into the short form. Short form means, so this number can be write using the decimal point as 8.5. So we simply write down 85. Simply write down 85 or the 8.5. That means this decimal point is transferred up to this position. So how many place? So firstly the decimal point is transferred from left to right. Decimal point is placed from left to right. So in this position, when the decimal point is shifted from left to right, that times the power of the 10 raised to the power is increased. 10 raised to the power is increased. So here decimal point is shifted from left to right. That time, just here 8.5 means how many place? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So 8.5 into 10 raised to the power 12. 10 raised to the power 12. So here and 12 from left to right, that times the 10 raised to the power. So power term is decreased. So therefore minus 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So decimal point is transferred to the 8.5. How many places? 12 places. And negative sign for transformation from left to right. And it can also be written as 85 into 10 raised to the power minus 13. That means when the decimal point transferred to the left to right again, so 8.5 into 10 raised to the power minus 12 and also minus 1. Minus 1 because this decimal point is shifted from 8.5 to 85 here. So this 85 into 10 raised to the power minus 12, it is the standard form. This is also standard. Now again in second equation we have to transfer this decimal point from here up to the point here. If we write down 9.4, 42 or 49.94.2 etc. So if we transfer up to that position, so here again transfer to up to that position, again from left to right. So we simply write down 94.2. Now count these places: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 94.2 into 10 raised to the power minus 13. Negative sign indicates the transformation from left to right. So this decimal point transferred to this side. It is also written as 942 into 10 raised to the power minus 14. Understand? It can be also written as 9.42 into 10 raised to the power minus 12. This also answer, this is also answer, this is also answer. So this is the standard form. Now just concentrate here in third example. in this number 602 and 000000000 up to so on. So in this number there is a no decimal point, then you consider the decimal point at the last, that means here, and again this is the 0. The decimal points, number of zeros after the decimal points are negligible, so it is not meaningless. Okay, so it is meaningless. So this decimal point convert into 602, that means 602 means we have to convert this decimal point up to that position, means यहाँ से लेके ये decimal point यहाँ तक आएगा, and this transformation takes place from right to left. Then 602 into 10 raised to the power. Now count the place: 1 2 3 4 5 6 7 8 9 10 11 12 13. So 10 raised to the power 13. Here if we transfer the decimal point from right to left, then the sign is positive, that is an increase, and when left to right, then it is a decrease. So 602 into 10 raised to the power 13, it can be also written as 60.2 into 10 raised to the power 14. If we write down 6.02 into 10 raised to the power 15, etc. All are the answer. This is the standard form. Now in question number 4, here 0.0000000837. Now in this case we have to transfer this decimal point up to this position, that is the 83.7, and here the transformation again left to right. So here we simply write down 83.7 into 10 raised to the power. Count the places: 1 2 3 4 5 6 7 8 9 10. So 10 raised to the power minus 10. Negative sign for the transformation from left to right. It can also be written in the form of 8.37 into 10 raised to the power minus 9. It is also written as 83.7 into 10 raised to the power minus 11. It is also answer. Okay, and the last one is here 3186 1 2 3 4 5 6 0, 6 times 0. So here simply write down 3186 into 10 raised to the power. Now decimal point is here, and transferred from here to up to that position, that is right to left. So how many places? 1 2 3 4 5 6 7. So 10 raised to the power 7. It can also be written as 318.6 into 10 raised to the power 8. It can be also written as 31.86 into 10 raised to the power 9. It can be also written as 3186 into 10 raised to the power 10. All are these answers. So all are these standard form. This is the first question of the exercise 12.2. Now dear students, our question number is 2. Express the following numbers in usual form. That is, the given numbers are in the standard form and we just write down in a usual form. So our first question example is 3.02 into 10 raised to the power minus 6. So here we also write down 3.02 into 1 upon 10 raised to the power 6. So here negative exponent can be converted into positive. So therefore using the multiple of inverse. Okay. So 1 upon 10 raised to the power 6. Now here the 10 upon 10 raised to the power 6, this value present in the denominator, or the exponent is negative. When the exponent is negative, that time you just shifted the decimal point from right to left. That means simply write down the number 302 and decimal point is here. Then we have shifted this decimal point to the right to left. How many places? 6 places, and one place is a 3, but there are other places are absent, so therefore give the places. So 1 2 3 4 5 and 6. So this is the answer. That is, the answer is 0.12345 and this 302. So this is the usual form. This is a usual form. What happened in this example? Given example is 3.02 into 10 raised to the power minus 6. So here 10 raised to the power minus 6, that is the exponent is negative. So we just simply write down 3.02 as it is, and this negative exponent as in the form of positive, that is the 1 upon 10 raised to the power 6. Now here 10 upon 10 raised to the power 6, this value is present in the denominator. So that means the decimal point position in the given number can be shifted from right to left. How many places? After the 6. From where the 6? 6 can take place from the 10 raised to the power 6. So this number 302 as it is, and decimal point shifting from 6 places. So here 3 is a 1 place, second, third and remaining places are absent, so fill up by using the 0. So 1, 2, 3, 4, 5 and 6. After the 6 point shift 6 places giving the decimal point, that means 0 point something. Now here in next part, 4.5 into 10 raised to the power 0. 10 raised to the power 4. 10 raised to the power 4 means 1, 2, 3, 4. This is the value. That is a 10,000. That is 10 raised to the power 4. Okay. So here 10 raised to the power 4. So here just do the multiplication. 45 into 1, that means the 45, and this decimal point shifted after the how many places? Given the decimal point 1, 2, 3, 4, and this is shifted from the 1 place. So here, in other words, when the 45, or this is the 44.5 into 10 raised to the power 4, that means here 10 raised to the power 4, that is the exponent is positive. That time when the exponent is positive and the 10 raised to the power value given in the numerator, not in denominator, that time you can shift it the decimal point from left to right. Left to right. Okay, so therefore 4, 5. So here how many places decimal point shifted? 4 places. What is the 5? So 5, but 2, 3 and 4, and here is the decimal point. Okay, so this is the number. This is a number 45,000. 45,000, that is the after the 4 decimal points. In question number 3, again 3 into 10 raised to the power 8 meter per second. If you consider the meter per second, then it will represent the speed of the light. Okay, but here is the number 3 into 10 raised to the power 8. That means 3 into, here again exponent is negative, so 1 upon 10 raised to the power 8. Now the exponent value 10 raised to the power 8 present in the denominator, so therefore decimal point shifted from right to left. How many places? 8 places. So here simply write down 3, and 3 is the 1 place. So 1, 2, 3, 4, 5, 6, 7 and 8. Here is the decimal point. Understand? So answer is 0.7 times 0 and 3 is there. Okay, so this is the usual form. After that, in question number 4, 1.001 into 10 raised to the power 9. Here the exponent value is positive, also present in the numerator, so the decimal point shifted from left to right. How many places? 9 places. So simply write down 1, 0, 0, 1. So how many places done? 1, 2, 3. But we want to places 9. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Here is the decimal point. So this is the usual form of the given number. Fifth one is 5.8 into 10 raised to the power 12. Again here the exponent is positive and this value present in the numerator, and we have to shift the decimal point from left to right after the 12 places. So that means 1 place is 8. 8 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and here is the decimal point. here is the decimal point. Understand? So this is the concept. And the last one is 3.61492 into 10 raised to the power 6. Again exponent is positive and also value present in the numerator, so decimal point is shifted from left to right, So here how many places after the 6 digits? So 3 6 1 4 9 2. So here is the place are 1 2 3 4 5, 1 2 3 4 5, and this is the 6, and here is the point, and here is the 0 0. So dear students, this is the question number 2. Given numbers are in the standard form and we have to find out in usual form. Okay. Now dear students, our question number 3 is that express the number appearing in the following statement, write in the standard form. Write down in the standard form. Okay. So some numbers or some expression is given in verbal format. We can also write down in the standard format. So 1 micron is equals to the 1 upon 1,000,000 meter. So here we simply write down 1 upon here 10 raised to the power 6 in denominator, here 10 raised to the power 6 because 1 2 3 4 5 6. So here 10 raised to the power 6. So it can be also written as 1 into 10 raised to the power minus 6 meter. So 1 micron is equals to the 1 into 10 raised to the power minus 6 meter. Okay. So this is the first. Second one is the charge of an electron is, in the first example 10 raised to the power 6 is present in the denominator. When it will be transferred into the numerator, its exponent converted positive to negative. So therefore 1 into 10 raised to the power minus 6 meter as it is. Okay. No, not a meter, it's a micron. It's a micron. It's not a meter. It's a micron. So charge of electron is, so here charge is given. So this is all over the charge. So now charge of an electron is, so we simply write down, look at here is the decimal point, and after this this is the value. So we have to transfer this decimal point up to this point, that is the 1.6, that is the 1.6. So after the 1.6, count the places 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 19. So here 10 raised to the power minus 19 coulomb, minus 19 coulomb. So 1.6 into 10 raised to the power minus 19 coulomb, because decimal points are transferred from the left to right, therefore its sign is negative. And 1.6 into 10 raised to the power minus 90, it can be also written as 16 into 10 raised to the power minus 20 coulomb. Okay, so it is also possible. Both are the answers. Number 3, size of the bacteria is 0.000005 microns. So also we can write this here 5 into, so this decimal point transfer up to the this point, that is the 5 into, so 1 2 3 4 5 6 7, 1 2 3 4 5 6 and 7. So 5 into 10 raised to the power minus 7 micron. What is this? 5 into 10 raised to the power minus 7 micron. Then number 4, size of a plant cell is 0.00001275. So if we transfer this decimal point up to this point, 1 point, that means 1.275 into 10 raised to the power, count the places 1 2 3 4 5, so 10 raised to the power minus 5 micron, minus 5 micron. Okay, so you can also write down is 12.75 into 10 raised to the power minus 6 micron. You can also write down 1.275 into 10 raised to the power minus 7 micron. All are the answers. Okay, in the last, thickness of a thick paper is 0.07 mm. So simply write down 7 into 10 raised to the power minus 2 mm. So all of these are the answers of the question number 3. Okay, so these are the answers. Now dear students, our question number 3 is that express the number appearing in the following statement, write in the standard form. Write down in the standard form. Okay, so some numbers or some expression is given in verbal format. We can also write down in the standard format. So 1 micron is equals to the 1 upon 1,0,0,0,0. So here we simply write down 1 upon here 10 raised to the power 6. In denominator here 10 raised to the power 6 because 1, 2, 3, 4, 5, 6. So here 10 raised to the power 6. So it can be also written as 1 into 10 raised to the power minus 6. 1 micron is equals to the 1 into 10 raised to the power minus 6. Okay, so this is the first. Second one is the charge of an electron is. In the first example, 10 raised to the power 6 is present in the denominator. When it will be transferred into the numerator, its exponent converted positive to negative. So therefore 1 into 10 raised to the power minus 6 meter as it is. Okay, no, not a meter, it's a micron. It's a micron. It's not a meter, it's a micron. So charge of electron is. So here charge is given. So this is all over the charge. So now charge of an electron is. So we simply write down. Look at here is the decimal point, and after this this is the value. So we have to transfer this decimal point up to this point, that is the 1.6. That is the 1.6. So after the 1.6, count the places 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So here 10 raised to the power minus 19 coulomb. Minus 19 coulomb. So 1.6 into 10 raised to the power minus 19 coulomb. Because decimal points are transferred from the left to right, therefore its sign is negative, and 1.6 into 10 raised to the power minus 90, it can be also written as 16 into 10 raised to the power minus 20 coulomb. Okay, so it is also possible. Both are the answers. Number 3, size of the bacteria is 0.0000005 microns. So also we can write this here 5 into. So this decimal point transfer up to this point, that is the 5 into. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. So 5 into 10 raised to the power minus 7 micron. What is this? 5 into 10 raised to the power minus 7 micron. Then number 4, size of a plant cell is 0.0000125. So if we transfer this decimal point up to this point, 1 point, that means 1.275 into 10 raised to the power, count the places 1, 2, 3, 4, 5. So 10 raised to the power minus 5 micron. Minus 5 micron. Okay, so you can also write down is 12.75 into 10 raised to the power minus 6 micron. You can also write down 1.275 into 10 raised to the power minus 7 micron. All are the answers. Okay, in the last, thickness of a thick paper is 0.07 mm. So simply write down 7 into 10 raised to the power minus 2 mm. So all of these are the answers of the question number 3. Okay, so these are the answers. Now dear students, our question number 4 is, in a stack there are 5 books, each of thickness is 20 mm and the 5 paper sheets each of Now dear students, our question number 4 is, in a stack there are the 5 books, each of thickness is 20 mm and the 5 paper sheets each of thickness is 0.016 mm. Then where the question is that what is the total thickness of the stack? So in a stack there are the 5 books. In a stack there are the 5 books. So in a solution, in a stack in a stack. Number of books is equals to 5. Number of books is equals to 5. And thickness of the book, thickness of each book is equals to 20 mm. 20 mm. So here we just write down thickness of total 5 books is equals to 5 into 20. So here 100 mm. So thickness of the total 5 books is equals to 100 mm, because number of books is equals to 5 and thickness of each book is 20 mm. So thickness of total 5 books is equals to 100. Now number of sheets, number of paper sheets is equals to again 5, and thickness of each paper sheet is equals to 0.016 mm. So the total thickness, or the thickness of total 5 sheets is equals to 5 into 0.016. So here 16 5s are 80. So here 1 2 3 and decimal point. So here is a total thickness of the sheet is 5. So we have to calculate the total thickness of the stack. So here we have to find out the total thickness of stack is equals to thickness of total 5 books plus thickness of total 5 sheets, 5 paper sheets. So here is means 100 plus 0.080 mm. So here answer is 100.08 mm. So this is the total thickness of the stack. It can be also written in the form of 1.0008 into 10 raised to the power minus 2 mm. So this is the thickness of stack. This is the thickness of stack. So this is the example number 5. In this example, we have given a stack. There are the 5 books and thickness of each book is 20 mm. So therefore thickness of the total 5 book is 5 into 20, that is the 100 mm. And also there are the 5 paper sheets. So number of paper sheets is also 5. And thickness of each paper sheet is equals to 0.016 mm. So the thickness of the total 5 paper sheets is equals to 5 into 0.016. So therefore total thickness of the paper sheet is 0.080 mm. So now we have to find out the total thickness of a stack. A stack contains the total 5 books and total 5 paper sheets. So adding their thicknesses, so 100 plus 0.080, that means 100.08 mm. It can be also written in the form of 1.0008 into 10 raised to the power minus 2 mm. And this is the final answer. Okay. Here 10 raised to the power square.